This is question 4, C3, January 11. We have to express 24 sine theta plus 7 cos theta in the form of r sine theta plus alpha. In the formula book, you're given a formula for sine of a plus b, which is this one here. Sine of a plus or minus b equals sine a cos b plus or minus cos a sine b. And that can be found on page 3 of your formula books. Now, this does look pretty similar to this. If I change this to sine of theta plus alpha, I've got the top sine here, so I'll use the top sine over here. It was sine of the first symbol, cos of the second symbol, and I'm on the top sine, cos of the first symbol, sine of the second symbol. But I had an r in front of this over here, so I'll put an r in here and an r in here as well. And we're saying in this question, this is to be written like this. So we're saying this and this are going to be equal. So what we're going to do now is I'm going to compare these bits, and I'm going to look at sine theta up here. Where's there a sine theta here? It's here. This sine theta in the question is being times by 24. This sine theta here is being times by r cos alpha. So I'm going to equate those, put them equal to each other. And I'm going to do the same thing with a cos theta. In my question, cos theta is times by 7, and in this expression here, my cos theta is being times by r sine alpha. When you get to this stage, what you always do is you square and add. You do it with the left-hand sides first of all, so it's 24 squared and 7 squared I'm going to add together. And then the right-hand sides, which is r cos alpha, I'm going to square, and r sine alpha, I'm going to square and add those together. If you work out 24 squared plus 7 squared, it's 625. And over here, this is the same as r squared cos alpha plus r squared sine squared alpha. Should have had a squared in there, cos squared. You can take r squared out as a factor here, and you get cos squared alpha plus sine squared alpha. And as an identity, you should know that sine squared plus cos squared equals 1. So everything in that bracket equals 1. So I get 625 equals r squared. And the question told me that r was positive, so r will be the square root of 625, which is 25. So I now know what r is, and I can go back to my equation up here, and I now have 24 equals 25 cos alpha. So I've just changed that r there into a 25. Move the 25 across where it becomes a divide. If I divide both sides by 25, I get 24 over 25 equals cos alpha. So I can find out what alpha is by doing an inverse cos of 24 over 25. The question says I'm looking for an alpha value between 0 and 90 degrees, and if I do it on the calculator, I get that alpha is 16.3 degrees. So I know my alpha and I know my r. The question was looking for an r sine theta plus alpha, and I now know that r is 25, and I know that alpha is 16.3. So I can indeed rewrite the question, or the expression in the question, in the way they wanted me to. Continuing with part B of this question, I'm told to solve this equation, where the first bit here, the left-hand side, is what we've had in part A. So I can rewrite it the way I rewrote it in part A, and I get this. So I've now got to solve this for theta, getting answers between 0 and 360 degrees. So the first thing to do is divide both sides by 25, which will give me sine is 12/25. And then what I can do is inverse sine both sides, so that will give me values for theta plus 16.3 is inverse sine of 12/25. And if you inverse sine that, you get 28.7 degrees. So I've got 28.7 is the first answer for theta plus 16.3, excuse me. But if I just draw the cast diagram, I've got a sine value which is positive. Sine being positive appears here, and that's that 28.7 I've just found, and also over here, where that would also be 28.7. So the proper name, if you like, for that angle there, coming all the way around this way, anti-clockwise from 0, that will be 180 take away 28.7 degrees, which works out to be 151.3 degrees. So I got these two answers for theta plus 16, but I don't want an answer for theta plus 16, I want an answer for theta. So I need to take 16.3 off both of these answers, which give me 12.4 degrees, and taking 16.3 off that one, I get 135 degrees. So 12.4 and 135 degrees are the answers for theta.